Let's start off reviewing the data path. So we're going to do this in three parts. We're going to first go through and have you list all the parts of the data path, then show what their inputs and outputs are, and then finally connect everything up. So parts of the answer of this are ahead, so don't skip ahead when you're doing this. So let's get started. Go ahead and list all the parts of the data path. Here's some extra space. All right, now for the second part, go ahead and add the inputs and outputs to each of the parts. So here are all the parts of the data path. I have over here the PC and the register file. Over here the instruction memory, branch adder, the PC plus 4 adder, sign extender, shifter, branch adder, ALU, and the memory. So now go ahead and add all the inputs and outputs for each of these parts. Finally, go ahead and connect everything up. So how does this data path move data around? So let's take a look at what we have. Here's our data path. You can see we store the PC here. The next PC comes out, it goes into the instruction memory, reads the address, it takes the PC as the address in the instruction memory, out comes the instruction. We use different parts of the instruction for different things to control the registers we read from. Part of it gets sign extended. The sign extended result goes into a MUX. The data coming out of the registers goes into the ALU. The ALU then does an operation, which it then can send into the address of the memory, or it can send data into the memory, and then the result coming out is either the result of the ALU, or we can take the data we read from the memory. We choose which one we want, then we send it back to write it back into the register file. Now at the same time up here, we take the PC, we add 4 to it, and then we're going to choose that as the next PC, or we can take the sign extended immediate and shift that and add it in for the next PC for a branch. So if you look at this here, what you see is that it has everything except the control in it. Now, how does this work? Well, we have our next PC waiting here, and we have that on the clock signal comes in, our next PC is going to become the current PC. When it becomes the current PC, it's going to go into the instruction memory. We're going to read out the next instruction. The next instruction is going to go into these parts of the data path. We're going to read out the register file information, and that's going to come out. We're going to take the sign extended part. Sign extended is going to go into the MUX, and we're going to choose it for the ALU. Because we're looking at an addi instruction. So this is an I-type instruction. We're going to use an immediate. In this case, the ALU is going to do an addition. Take the result of that addition. We're going to put it back to write into the register file. Now, this new register file value is waiting here. What happens is, at the same time, we're taking our PC, current PC, we're going to add 4 to it, and we're going to send it around here, so we have the new PC waiting at the PC register. Now, the clock signal comes along, and what happens when the clock signal comes along? Well, we're going to take these things that are waiting, the new PC, and it's going to become the current PC, and the new data for the register file, and we're going to save it in. So we go ahead and save those things into our register file and as our PC. Now we've got our new next PC and new data in the register file, and repeat the whole thing all over again.